Plate tectonics as a whole tells us about Earth before our time began. Through plate tectonics, we were able to discover mysteries about Earth's past, which may help dictate Earth's future. Plate tectonics is a scientific theory that explains how major landforms are created as a result of Earth's subterranean movements. The theory, which solidified in the 1960s, transformed the Earth's sciences by explaining many phenomena. There are three different types of plate boundaries we will go through: convergent, divergent, and transform. When two plates come together, it's known as a convergent boundary. The impact of the colliding plates can cause the edge of one or both plates to buckle up into mountain ranges, or one of the plates may bend down into a deep seafloor trench. We have oceanic, which occurs between two oceanic plates. One of those plates will subduct beneath the other. Normally, the older plate will subduct because of its higher density. We also have oceanic continental convergent, which occurs where there's an oceanic plate converges with a continental plate and subducts under it. Finally, continental is when two continental plates push up against each other, creating mountain ranges. A divergent boundary occurs when two tectonic plates move away from each other. Along these boundaries, earthquakes are common and magma rises from the Earth's mantle to the surface, creating a new oceanic crust. A transform boundary is a place where two of Earth's tectonic plates move past one another. As these plates move past one another, the plates interact and can create cracks or faults within the surrounding area. An example of this is the San Andreas Fault.
The effects of plate tectonics. Tsunamis are generated during earthquakes at ocean trenches. Trenches are formed by subduction, a geophysical process in which two or more of Earth's tectonic plates are converging. Earthquakes are sudden shaking of the surface of the Earth due to a sudden release of energy from the lithosphere. What makes them move? Plate tectonics move because of three main reasons. One reason is due to the mantle convection currents. These warm currents carry the tectonic plates and make up the lithosphere underneath the Earth's crust. The second reason is through ridge pushing, which occurs when the upwelling mantle continues to move at ridges placed on the mid-ocean level. The third reason is due to slab pulls. This force occurs when the older plate starts to sink. As the plate ages, they become colder, which makes them more dense. They then start to sink and pull the warmer part of the plate with them. Active versus passive margins. The distinction between active versus passive margins refers to whether a crustal boundary between oceanic lithosphere and continental lithosphere is a plate boundary. Active margins are found on the edge of a continent where subduction occurs. Passive margins are only passive in that they are not active plate boundaries. Mid-ocean ridges is a seafloor mountain system formed by divergent plate boundaries. The mid-ocean ridge is the most extensive chain of mountains on Earth, stretching nearly 40,390 miles, and with more than 90% of the mountain range lying